Okay, so I'm starting with generative AI. So let's start for the basics of generative AI, which is in quite hype these days. Moving on to the first slide. Okay, so let's start. What is generative AI? So understanding this generative AI, it could be understood like its main goal is to create new data on the basis of what it has learned from its previous data. This is the main basis of generative AI. For example, we can give 10 pictures of cat and 10 pictures of dog to generative AI and now ask them to create a new picture of a dog. So it will come up with a new completely different picture of dog. For example, we ask them to create a new picture of dog in the space shuttle, so it will come up with a new picture of that. So this is what the basis of AI. And one more example I can help you is that we can also predict the next data or the next words of any sentence on the basis of generative AI, which works on the basis of probability. For example, if I say a sentence like, my sister lives in dash. Now it will come up with the options like New Delhi, London, bedroom, floor, etc. Now it will calculate the probability of all that and will give the best suitable answer for it. So this is all about generative AI. Moving on to next slide, how it actually works. So generative AI works on the principle that all the data present all over the internet is being fed into it, or rather I can say the entire world wide web is being crawled, and its training corpus is entire internet. Then after that, that data is a raw data and unlabeled data. Unlabeled means that are not segregating or classifying it on any basis. Then we do sanitization of it. Sanitization means that we remove all the critical or harmful links or any critical harmful hateful comments, anything like that. We remove all of that from it, and then we go for word embeddings. What is word embeddings? It's actually the generative AI focuses on understanding the relationship between several words present in world wide web. Like for example, a dog and a cat. So on the basis of data which was being showered on the generative AI previously, it will get to understand that there is a certain relationship between a dog and a cat, right? So this is what word embeddings means that it classifies certain words in certain niches according to their relationships. Next is the language model. What is a language model is means classification, vector classification on x and y axis. As you can see in the graph here, it has classified certain words on the x and y horizontal and vertical axis. And the technique which is used here is word to vec, which is used to convert a word to a vector form, so that it could be used in NLP. NLP is natural language processing, means that we can use generative AI for the application of these. For example, sentiment analysis, speech language understanding, on which Alexa works, and everything like that. Like for example, understanding the what you say, the prediction of next words, etc. So as you can see here on the graph, there are two words like dog, cat, and animal. So they all are classified in one genre because there's a certain relationship between dog, cat, person, walk. Because, for example, these are all are living, so that's why they are classified on one genre. Like this, there are billions of parameters on which they are being trained. What are parameters? Parameters are actually data sets on which these are being trained. Now let's moving forward, we will understand the logic behind text to image. So what is text to image? Actually, there's it's a combination of language and image. Language means that word embeddings. What does that mean? As we have already discussed, it will it will try to find the relationship between several words and several sentences present over the world wide web, and then it will classify on that. Similarly, coming to image, it will do pixel learning, means that it will learn the visual structure moving from top to bottom and learn pixels from moving from top to bottom, x y axis, horizontal and vertical lines. And then understanding the relationship of the pixels, it will embed both of these, language and image, to to a combined model which is text to image generation. And one of the best examples we can see here is stable diffusion model. Fine. So now let's moving to the next thing, how the diffusion model is trained for noise. So prior to this, let me introduce you that diffusion model basically is used for image creation, text to image creation. So we can see here there are several images of a man. The first image is the original image. Then we ask the generative AI to add some noise over it, so it blurs. Then we add further more noise over it, then it completely blurs. Now on the second line, on the second horizontal line, we will see the complete blurred image. Now we will ask the generative AI to remove some amount of noise, so it creates the next image which is a little bit blurred. Now it we ask again to remove all the noise. Now it will create the final image, that is original image. So this is just a basic understand, this is just how the diffusion model is being trained in a reverse process. That is, it first learns to add the noise and then it learns to remove the noise. Okay, I hope I'm making sense. Then now moving to the next slide, parameters. Like, what do you mean by parameters? Parameters means that where machine learning algorithm has learned from its data set. For example, we are creating a data set of emotions where every emotions are being restored, are being stored. For example, anger, passion, joy, fun, everything is being stored in that. So the the large language model is being trained on that parameter. So this is one of the parameters it is being trained. Similarly, the language models, the upcoming language models, which we can see as like for example GPT-3 and upcoming models like BERT and all these things like we see Bing and etc., which are really very amazing in comparison to human brain. So these models are trained on billions of parameters, right? And these are also called as foundation models. Now what are foundation models? Foundation models are like parent models which have all the capabilities, which are being trained rigorously on various parameters, so that they understand and they predict the natural language very comfortably. Okay, so for example we can see that bird is trained on 340 millions of parameters, means that there's 340 data sets, several different variable data sets on which it has learned. Similarly, GPT-3 is trained on 175 billion parameters. So just to let you know, more number of parameters it is being trained, sorry I just missed the slide, the more number of parameters it is being trained, the more highly efficient it is. And apart from that, the more number of parameters it will be trained, the more GPU it will be using, and it will be having sorry, it will be costing more expenses, that is, it will be more expensive. Okay, now just moving on to next slide. Just letting you understand few of the terminologies in the field of AI. So one shot inference. One shot inference means that we are giving a prompt to artificial intelligence, so that it can undergo a particular work. So in that thing, if we include one of the examples, like for example, we are giving a speech therapy type of prompt to a artificial intelligence, to a chat GPT thing or Bing or anything else. So in that case, if we are adding one of the examples, like we are saying, if a person is angry, ask him in a very polite and peaceful manner, make him to calm down and do all this etc. For example, if we add one of the examples like, if the person is happy, ask him, the chat GPT should ask him, or any of the AI should ask him that how is the day going on. So if you are providing one of the examples, it is called as one shot inference. It will help the generative AI to create that sorry to do the task more effectively. Similarly, few shot inference means that we are providing more than one examples. But if you're not able to provide more examples because of this number limit, or what do you say, alphabet limit, then we have to do the fine tuning. Now what is fine tuning? Fine tuning means that we are adding features to the generative AI. Just like, for example, we have created a dish, and for example, we have created something sweet like what do you say, something like gajar ka halwa. Okay, so in that thing, might be possible we have at the end of it, while we are tasting it, it might be possible we are adding some cashews on it, cashews and nuts and something else to make it more delicious. So fine tuning is a similar thing. We're adding certain specifications and features so that the large language model could work in a more better way. Next, now,